We will begin with the first question, which shows $3,015.01. By using place values, we will be able to arrive at the correct answer. So let us therefore write down the place values to include the largest place value in the number given. The largest place value is 1,000, so we are going to write down the place values in order that we will cater for the highest place value. The largest place value is 1,000, and since we are dealing with monetary values, tenth and hundredth will be the two decimal places implied. Let us include the decimal point. So let us write that decimal point exactly where it should be written. Let us write the number down using the place values as a guide. 3,000. The 3 will go in the thousands column. Okay, so there's no difficulty with that. We have 3,000, and so we have a 3 in the thousands column. $15. By moving immediately to 15, we realize that there is no hundred. We will therefore place 0 in the hundreds column. 15 means 110 and 5 ones. We will therefore place 1 in the tens column and 5 in the ones column. $0.01. Cents are out of 100 and therefore have two decimal places. There is only 1 cent, which means 1 out of 100 or 1/100th. The 1 will therefore occupy the 100th place, and there being no tenth, 0 will occupy the 10th position. So we have 1/100th and we have no tenth, so 0 will occupy the 10th position. The answer is option A. What is 38.5 plus 11.82? When adding or subtracting numbers that have decimal places, the points must be placed one below the other. Write down the first number. That is 38.5. We will write the other number by first putting the point vertically below the point. So the points must be vertically aligned. Write the digits to the left of the point, putting the one closest to the point first. So we are going to put the digits to the left and the one closest to the left. So we are going to write down 11.82. We have the point already down. We are going to put this one. It is closest to the point. We put that one first, then we put the other. Write the digits to the right of the points, putting the one closest to the point first. So we have 0.82 right here. So next to the point we have the 8, so we'll write that 8 down first, and then we'll write the 2. Although it is not necessary, let us put a placeholder 0 above the 2. Add the numbers beginning at the column that is to the extreme right. We may include the point first. It is placed vertically below the other 2 points. Now we are going to add the digits in the first column. 0 plus 2 is equal to 2. Write the 2 vertically below the digits that we are adding. Move on to the next column. 5 plus 8 is equal to 13. Write the 3 and carry 1 to the next column. Move on to the next column. So we have 1 plus 8 plus 1 is equal to 10. We are going to write that 0 and carry 1 to the next column. And of course, finally, we will add the digits in our final column, and we have 1 plus 3 plus 1 is equal to 5. So we'll write that 5 right down right there. And which one does it appear to be? The answer is option D. Here we have another lovely problem, problem number 3, that requires that we add. And we have a lot of variations. We have decimal places, and we have figures in dollars, and some are given in cents. As a matter of fact, a single one is given in cents. And Jerry Lewis is going to tell me what to do when we get to the part with the cents. So Jerry, be careful now that you don't make a meal of this problem. Make sure that you start to take a good look at it, that when we get there, you will not be stuttering at all. As in the previous problem, when adding numbers that have decimal places, it is appropriate to place the points vertically below each other. Although we are working with dollars and cents, we do not need to write the dollar sign as yet. Write down the first amount, 15.15. For the second number, write the point under the point of the first number. So we are going to align the points as usual, right? And then write the number on both sides of the point. So we are going to just put that in exactly as we have right here. So 0, 7 on the right of the point, and 3 on the left. So there we have that 0, 7 and 3 on the left of the point. The next number is not accompanied by a point. The point is assumed to be at its extreme right. So 72 here is not accompanied by any point, or we don't see any decimal place at all. So we assume that the point is on the right. Placeholding zeros may be included in order to complete the decimal places. 2 is given in cents. 100 cents make a dollar. We will divide 2 by 100. So, Jerry, your time. Although I have stated what the problem is all about and a part of the solution, I am going to take instruction before I reach to the other slide. No, Jerry, you cannot say the same thing that I've just said. And I don't want you to read information from the screen. I want some good instructions from you right now. Very quickly. Okay? Alright, so how do we progress? By long division, or we are going to take a short method? I shouldn't have given Jerry the option because Jerry is always going to take a shortcut. So let us move to the next slide. When dividing 2 by 100, we desire to reduce its value by 2 decimal places. In all whole numbers, the point is assumed to be at the right. Let us now reduce the value of the number by 2 decimal places. The new position of the point relative to the digits will be located 2 places to the left. There is only 1 digit, so a 0 will have to be included in order to complete the required number of decimal places. So we are going to reduce this number, which is 2, by 2 decimal places. That is what we do when we are dividing by 100. Of course, we only have a single digit. Because we have a single digit, we are going to include another digit, which is a 0, to complete the required number of decimal places. So it will be located 2 decimal places. We have to put a 0 now. 2 decimal places to the left relative to the position of the digits. And of course, we may write a 0 in front of the point right there. We may also say that the new position of the digits relative to the point are located 2 decimal places to the right. Whether we think decimal point or digits, the relative position may be such that it constitutes a reduction of the value of the number 2. the number by 2 decimal places. So some may say that the position of the digits relative to the point, and some may say the position of the point relative to the digits. The movement or the assumed relocation of the digits or the point is always relative. So if one is pushed in a direction to the left, then the other automatically is placed in a direction to the right. So it doesn't really matter. Write 0.02 under the numbers and add them. So this 0.02, don't forget, Jerry, that we are solving a problem in which we are required to add currency. Therefore, we have to continue by adding the 0.02 to the others. And there we have it. So let us add. Add the digits in the hundredths column. Let us do that. What do we have? 5 plus 7 plus 0 plus 2. And that is equal to 14. And write down 4 and carry 1 to the 10th column. Add the digits in the 10th column. We only have 1 plus 1. We have 3 zeros. 1 plus 1 plus 0 plus 0 plus 0 is equal to 2. So write down the 2. We don't have anything to carry in this case. And put the point under the points, vertically below them. Anything to add again? Of course, we have to continue until we are through. So we have there 5 plus 3 plus 2 plus 0, and that is equal to 10. So for the 10, we write the 0 down and carry the 1 to the tens column. Finally, we add the digits in the tens column. 7 plus 1 plus 1, or 1 plus 1 plus 7 will turn out to be 9 in any case. So that is our answer. We may now declare our answer using the $sign. The answer is 90.24, and the option is A. Of course, Jerry, we do not have to write the $sign at every single stage of the game. However, we need to make it clear at the end that we are dealing with currency by putting the $sign in our answer. What is the value of the digit that is underlined in 25.068? This is one of your favorite, Jerry. You just put in the place values and then you just pick the digit out and you are finished. It's as simple as that. So the number and the place value of each digit will be shown below. There we have it already. The one that is underlined, what do we have to say about it? The underlined digit is 6. It is in the hundredths position. Hundredth means out of 100. The fraction that represents 6 parts out of 100 will be the correct answer. The correct answer is option C, 6 parts out of 100, or 6 hundredths. What is the value of the 7 in 27,800? So let us write that, and of course you know what we are going to do with it, right, Jerry? You love these problems because you don't have to calculate a thing. You just need to know the place values, and then you have the solution. Let us first indicate the place values of each digit. Tens of thousands, thousands, hundreds, tens, and ones. But usually we start here. Ones, tens, hundreds, thousands, tens of thousands. The 7 is located in the thousands column. It is therefore 7 thousands. So it represents 7 thousands. According to its position, it should have 3 digits to its right. The one that has the 7 with 3 zeros to its right is option D. And that is our correct answer. For a good deed, a boy got $56 in addition to his regular allowance of $649. How much did he get? There are two clues as to which arithmetic operation to use in solving the problem. The first one is the word in addition to. This is telling us that we are required to add. The second clue is that we expect the boy to get more than his regular allowance. If the amount is more, then we are expected to add. We may add the numbers in any order because addition is commutative. And what does commutative mean, Jerry? Very good. It means that the order in which we add numbers does not affect the result. So if we say 7 plus 5 is equal to 12, 5 plus 7 is also equal to 12. So, addition is commutative. But, let us write down his regular allowance first. Usually we try to put the bigger number first. So we write down the regular allowance. And then what do? Of course, we have the hundreds, tens, and ones, although it's not a complete necessity. But this technology has its way of making life very easy for us. 56 needs to be written down with the ones digit under the ones digit and the tens digit under the tens digit. Very nice. 9 plus 6 is equal to 15. So Jerry could take over from me right here. Write down 5 and carry 1 to the tens column. 1 plus 4 plus 5 is equal to 10. Write down 0 and carry 1 to the hundreds column. Then finally, 6 plus 1 is equal to 7. So we just write the 7 down. And that's all there is to it. Well, that was not all. We needed also to include the dollar sign. The correct answer is option B. What is 49,058 written in numerals? We will use place values in helping us to solve this problem. 49,000, what does that mean? We will begin at tens of thousands because 49,000 has 9 thousands and 4 tens of thousands. So 4 tens of thousands will go first. Next we will have the 9 thousands. 58. The phrase 58 tells us that there are 5 tens and 8 ones. So first place the 5 in the tens column and next place the 8 in the ones column. The 100 place is empty and may be occupied by a place holding 0. The correct answer is option D. Now we have some nice problems. As Jerry sees this problem, he's having a terrible headache. What is the sum of 0.023, 0.05, and 0.09? Right. Because of the decimal places, he's terrified. When adding numbers that have decimal places, it is appropriate to place the point vertically below each other. So we're going to place the points vertically below each other. Write down the first amount, 0.023. Now, for the second number, write the point vertically below the point of the first number. So, put the point down and write the digits on both sides of the point. So we have 0.05. 0.5 is going to be on the right side of the point and 0 on the left. Like so and like that. Write the point of the other number. So we have 0.9, and we are going to write the digits on either side of the point. Although it is not completely necessary, placeholding zeros may be included in order to complete the decimal places. Okay. So what do we do now? Add the digits in the rightmost position. So that is the rightmost position, and that is where we begin. We usually call the rightmost position the position of what? Least significance, because those digits have smaller values than the one next to them. So 3 plus 0 plus 0 is equal to 3. With nothing to carry, we just write the 3 down. 2 plus 5 plus 0 is equal to 7. Nothing to carry again, write the 7 down. This is fun now, Jerry, isn't it? You just add and you just write down and you move along. Nothing to carry. 0 plus 0 plus 9 is equal to 9. Write the 9. That's all there is to it. And do not forget your point. Okay. The sum of all the zeros in the final column will be equal to 0. Of course, when we add all those zeros, we still get 0. And that's all there is to it. Now, Jerry, I'm just hearing Jerry Lewis saying now that if he knew it would have been so easy, he would have taken over and he would be very happy to volunteer to solve that one for me. Too late, Jerry. You ever hear this saying? No practice after race? Right, that saying has been fulfilled on Jerry Lewis. No practice after race. The correct answer is option B. Jerry, when you get another one that looks like this, I hope that you put your hand up very quickly and you take it over, right? Okay, good. There's another one. If you're not on the alert, it is just like this one. But if you're not alert, you will not realize until it is too late and you cannot solve it again, because I would have solved it for you already. So pay attention now. The Venn diagram below shows two sets. What are the elements of set X? Let us highlight the set X. So, that's your set X, all covered in red, and you see the elements there. So let us then write down the elements in the highlighted set in numerical order, beginning with the smallest one. So, 2, 3 is in there, also is 4, I can see other 6, and I can see 8. That's very nice. The correct answer is option B. What is 5/10 plus 100 plus 8,000? 5/10 means 5 out of 10 and may be written as a fraction, 5 out of 10, like that. 100 means 1 out of 100 and may be written as a fraction. 8,000 mean 8 out of 1,000 and may also be written as a fraction. The number of zeros in the denominator tells us the number of decimal places that the decimal fraction should have. So that should have what? We have 1 0. So how many decimal places, Jerry? 1 decimal place. 1 decimal place, 0.5. 2 decimal places, 0.01. 3 decimal places, 0.008. And now, Jerry Lewis is just discovering that we have solved a problem like that before. And I'm not going to allow him to work it out. I'm going to give you a harder one, Jerry. So this is the problem that I told you about not too long ago, Jerry, that we are going to have one just like it. Yes. And you should be on the alert, but you are just captivated by the computer program, so you didn't realize. So we will then proceed to add the numbers beginning at the rightmost column. Notice that the placeholding zeros are not included this time. Of course, the placeholding zeros are not necessary. They are just placed there to cause the entire thing to look balanced. Right? So we may just proceed. So we say 8. There's only 8 there to be added. Then we have 0 plus 1 is 1. Then we have 0 plus 0 plus 5 is 5. Right? The point vertically below the point. And eventually the 0. So the correct answer is option D, 0.518. Which is an even number? An even number is divisible by 2. We can identify them because of the fact that they end with the digits 0, 2, 4, 6, or 8. Any number that is not even is odd. Odd numbers are not divisible by 2. Instead, they end with the digits 1, 3, 5, 7, or 9. The only even number is 4. The correct answer is therefore option B. Which shows a set of numbers greater than 8 but less than 16. The set that will satisfy the requirement as laid out in the statement of the problem must have all elements greater than 8 and all elements less than 16. In the first set, we have an 8 right here. 8 is not greater than 8. Therefore, the set A is not correct. 8 is also present in the second set. The second set, B, is also eliminated because of the same reason that we eliminated the first one. All of the numbers in this third set, C, are greater than 8. But this is not all. The numbers are also required to be less than 16. The set contains 16, which is not less than 16. The set C is not the correct answer. At least not the correct answer that we are looking for. Apart from the fact that we have eliminated all of the other letters, making D the automatic answer, we may check to ensure that each number is greater than 8 and at the same time less than 16. See? 9 is greater than 8, also all the way up to 15. And of course, they are required to be less than 16. 15 is less than 16, so is 13 and all the way down. The correct answer is therefore option D. Which ratio is the same as 2 to 5? We may use a quick analysis to eliminate 2 of the options. Notice that in the statement of the problem, the first number in the ratio is less than the second. So notice that this number is less than this. The proposed answers that have the larger number first are therefore incorrect. So notice that in the statement of the problem, we have 2, the smaller number first, then 5. Now here we have a bigger number, smaller, bigger number, then smaller. So we know that these are automatically out. We may attempt to show that the ratio 6 to 15 is the same as 2 to 5. This can be achieved by reducing the ratio 6 to 15 by a common factor of 3. 3 may divide into both 6 and 15. So there we have 6 to 15. 3 into 6 is 2. 3 into 15 is 5. By reducing the ratio 6 to 15 by a factor of 3, the result is 2 to 5. And that is the one that we have in the statement of the problem. So 6 to 15 is the same as 2 to 5. The correct answer is option C. The ratio 1 to 4 cannot be reduced and is not in any way the same as 2 to 5. We have a problem right here, and we have many stars here. If 5 fewer squares had stars in them, what fraction would then have stars? So what fraction of the entire thing would have stars if 5 fewer stars were there? So in order to find out the fraction, we would do what? Count all of the squares and count all of the squares that have stars. So we'd count all of the squares that we have here and then count all of the squares that have stars. And of course we could make our necessary calculations. But when we have a rectangle in a system like that that is divided into many other rectangles, or in this particular case many squares, then we can take a shortcut in finding the number of them. So do not count all of the squares. Count the squares in both horizontal and vertical directions. So count the squares vertically. 2, 3, 4, 5. Then what do? We have 5 of them. Count the squares horizontally. 5, 6, 7, 8, 9, 10. So 10 of them. Multiply the number of rows and the number of columns to get the total number of squares. So we have 5 times 10 is equal to 50. So in all, we have 50 squares. 3 rows of 10 squares each have stars. The number of squares that have stars is equal to 3 times 10 is equal to 30. Notice that we have how many have stars? 1, 2, 3. And we know that we have 10 of them across. Therefore, we know that we have 3 times 10, so it's 30. 30 have stars. But remember, the statement of the problem says 5 fewer. So 5 fewer means less, of course, 5 less. We will have to take away 5 from 30. So 30 minus 5 is equal to 25. So if 5 fewer squares had stars, we would have how many stars? 25 stars. The fraction is 25 out of a total of 50. So 25 over 50, 25 out of 50. This may be reduced by a common factor of 25, because we are sure that 25 can go into 25 one time and 25 into 50 two times. So the fraction now is a half. The correct answer is option C. The table shows a list of some items in a store. What is the total cost of items A, D, and E? So take note of items A, D, and E and their associated amounts. So their cost will be shown right there. Very good. Write down the first amount. There we have it. It's coming right from here. Good. Write down the other amounts as usual with the points below each other. So the points must be aligned in this section also. Very nice. Okay. There we have them. Add the amounts beginning at the right. So zeros all to be added. The result is 0. Zeros all again to be added. The result is 0 again. In the other one, what do we know? Zeros and a 3. So 0 plus 0 plus 3, and that is equal to 3. Now 5 plus 9 plus 6. What's that equal to? 20. So we write down the 0 and we carry 2. And again, what do? 2 plus 0 plus 8 is equal to 10. So what do? Write the 0 down and carry 1 to the other column. And finally, 1 plus 2 plus 1 is equal to 4. Notice that in each of the suggested option, the 2 decimal places that represent cents are left out. This should not cause a problem because there is no cent in the answer. So notice that the decimal places are left out of the answer. Of course, here we do not have any at all. Any cent. 0 cents. Therefore, we are sure that if we leave out the cents in the answer, then we would have done the correct thing. So the correct answer is therefore option C. Jerry Lewis is quarreling that I did not put the dollar sign right here. That's just an oversight, Jerry. I'll ensure to do that next time. A boy was asked to write 25 out of 75 or 25 over 75 in its lowest term. He wrote 5 over 15. What else should he do to get the correct answer? All of the incorrect answers may be eliminated in one step. So this problem we can just eliminate all the incorrect answer. This is because in a fraction reduction problem, both numerator and denominator has to be reduced by the common factor. The correct answer is therefore option C. See, this is saying divide the numerator alone. This one is saying divide the denominator alone. This one is saying divide the denominator alone. So we are sure that those are incorrect. If we are going to reduce a fraction, we have to reduce both numerator and denominator. Then we have to consider that when we are reducing a fraction to its lowest terms, we find a factor common to both numerator and denominator and divide both of them by the common factor. This is done until no common factor, with the exception of one that does not matter, may be found. And of course, if we divide this by 5 and this by 5, it would be reduced completely. What is 13 out of 52 as a percentage? 13 out of 52 may be best written as a fraction. Percentage means out of 100. We therefore multiply the fraction by 100. And of course, any whole number may be written as a fraction with 1 as the denominator. We may choose to reduce by a common factor of 4, but take the opportunity to show that we know that 13 is a factor of 52 by first reducing the fraction by 13. So we're going to reduce the fraction by 13 first, showing that we know that 13 can go into 52 exactly. And of course, 13 into 13 is 1, 13 into 52 is 4. We may now reduce the fraction by a common factor of 4. And of course, 4 into 4 is 1, and 4 into 100 is 25. The fraction becomes 25 over 1, and 25 divided by 1 is 25. So our answer is 25%, and this correct option is D. What is 85% as a common fraction? 85% means 85 out of 100. This may be written as a fraction with 85 as the numerator and 100 as the denominator. The fraction may be reduced by a common factor of 5. 5 into 85 is 17, and 5 into 100 is 20. The correct answer is option A. What is 3 over 1000 expressed as a decimal? The fraction is 3 thousandths. That represents 3 parts out of 1,000. It also means 3 divided by 1000. We will therefore divide 3 by 1000 to get our answer. And of course, we are going to be using a long method to do that. In an examination, we suggest that we use a shorter method, but we are exploring all of the methods that we possibly can in Richard James Mathematics Resources so that the students can be well equipped to handle any situation. First, we are going to say 1000 to be divided into 3. So 1000 cannot be divided into 3, so we place a 0 over the 3, then followed by a point, and say 1000 into 30. Again, this is an impossibility, so we do what? Have another 0 over the 0 in 30, and then we place another 0, increasing the value to 300. Then we say 1000 into 300, and this is also an impossibility. So what do? We place another 0 there because 1000 cannot go into 300. Right. So look at this. We have 1000 cannot go into 3. So 0 over the 3. Cannot go into 30. So another 0 there. Cannot go into 300. So another 0 there. And of course we are going to put another 0 right there. And what do? Finally, we say 1000 will go into 3000 3 times and place the 3 over the final 0. And that is our answer. The correct answer is option B. We may take a strategy from a previous problem to arrive at the answer in a simpler way. 3,000s mean 3 out of 1,000 and may also be written as a fraction, like that. The number of zeros in the denominator tells us the number of decimal places that the decimal fraction should have. 3 zeros. 3 decimal places. There we have them, 0.003, having 3 decimal places, and that's very, very simple. That is the one that Jerry likes. The answer is therefore option B. Jerry, it does not matter what you like. Make sure you learn every single method to prepare you for high school, because when you get to high school, you will not have just a single set of problems to solve. You will have problems of all different kinds. Therefore, your numeracy level will have to be very, very high if you are going to get a very good grade when you are finished with high school. So, it's not a matter of what you like, but make sure you can work efficiently with every method. What is 25 over 8 written as a mixed number? The fraction 25 eighths mean 25 divided by 8. 8 into 25 is 3 times. Then we say 3 eighths 24. So we are going to subtract that 24 from 25. And 1 is the result. The 3 indicate that 3 can go into 25 3 times, and it represents 3 wholes. There is a remainder of 1. Since we are dividing by 8, the 1 represents the number of parts that are left out of 8, and is therefore the numerator of the fraction, of which 8 is the denominator. Like that. Also, we could consider that we are still dividing. And of course, because 8 cannot go into 1, we are still dividing, so we say 1 divided by 8, and that is written 1 over 8, and it is 1/8. The answer is therefore option B, 3 and 1/8.